Hey guys, welcome to another lesson. So we're gonna start pulleys, right? Now, this is arguably one of the most difficult topics in the course. That's why I've divided it into a few different parts so that we can break it down, do it slowly, focus on some important things, and make sure you understand the concept well. Right now, just before we start, generally pulley questions on past papers, they are in two parts. The first part is the fairly easier part, which most people get the marks. And the second part is slightly more difficult because you have to um, understand the situation, see what's happening, and then model the situation from there. So that's slightly more tricky. So we are going to start with just the definition of what pulleys consist of. Okay. Now, um, so a pulley is a wheel that carries a string, right? So if you look at this diagram here, yep. So if you look at this diagram here, this is your pulley. Okay. And there's one string which is going around the pulley and carrying it to two ends. Okay, so this is one string. Okay, it's not two separate strings. That's a misconception. So there's one string which is going around, and there are two particles which are hanging on the string, right? So that's how a pulley situation looks like. This is a vertical pulley. Both strings are hanging vertically. Okay. Now, at this point, it's good to mention that a string can be two types. Okay. You can have a string which is taut. Okay. Taut means the string is fully stretched. It can't be stretched anymore. Okay. And slack is when it's not fully stretched. So if you look at this example here, the string is not fully stretched. It can be stretched further to make it taut. Okay. So coming back to this example, so here you can see the string is taut on both sides. We have a pulley connecting, and there are two particles which are hanging on both ends of the string. Okay, now both these particles will first they are held in rest, and then eventually we will release the pulley. One particle will go down, another particle will go up. Okay? And eventually the heavier particle will fall to the ground. Right? Now, before a particle falls to the ground, both particles travel same tension, speed, acceleration. Okay, so this makes it easier because you find the tension for one, it's the same as the tension for the other. You find the speed for one, it's the same as the speed for the other, and same with acceleration. Right, so as I said, the heavy particle goes down and the um, lighter particle will go up. Okay, so if you look at this pulley situation here, the heavier particle is 3 kg and the lighter one is 2 kg. Okay, so this 3 kg particle, this goes down. Right, so for this one, we are doing down minus up equals ma, right? Because it goes down, so we do the down first. This lighter particle goes up, right? So for this one, we will do up minus down equals ma. Okay, so it's really important you get those in the right order. Otherwise, you will get confused as we go along. Another thing to mention is that there's a force called tension. Okay, tension is a force which acts in a string, which always acts towards the pulley. Okay, so okay, now you see there's the pulley is over here. Okay, so on both ends of the string, there will be tension which is acting towards the pulley there. Okay, so this will be your two tension forces. This replaces you can say the normal reaction force in some instances. Okay, because both the particles are hanging in the air, right? They are not on a surface, so there will be no normal reaction. You will only have tension. Okay, so let's try to model the system here. So you can see there's a pulley over here, one string going round, two particles, okay, and that should be 4 meters. Um, so let's fix the diagram first. Right, so as you can see, both particles are 4 meters above the ground. So this is the ground over here. Both particles 4 meters above the ground. Now, the first thing we always do is write down the forces, draw the forces, right? So uh, going down, let's choose different color. Going down is weight. So for Cambridge, 3 times 10, 30, and 20. Okay. Going up will be your tension. And that's it. There's no other forces over here. Okay. So once we've done that, we can do F equals ma. Okay. Now, because one more important thing, because it's only one string going round, this is the same string, right? The tension is the same. So I've labeled both of them T, right? If you have a situation where there's two separate strings, which we'll come on to later, that will be two different pulleys, then you can't label TT. Then you label T1, T2, or some other letter. Okay, but don't worry about that now. At the moment, one string, so both tensions are the same. Now, for particle A, okay, A is going up, right? So we do up minus down. T minus 20 equals 2A. Okay, particle B. Now B is heavier, so B will go down, right? So we do down minus up equals MA. Right, now, once we've done that, we have two equations. We can solve them simultaneously. So whichever method you want to use, what I will do here is I will add both of these equations. Okay, so what will happen is t plus minus t will cancel. Okay, minus 20 plus 30 is 10. 2a plus 3a gives you 5a. And a equals 2. Right, once you've got a, you can find your tension by substituting into any of the equations, right? So if you choose the first one, right, a is 2, so substitute it into the a here. 2 times 2 is 4. T equals 24. Okay, and then it says find the speed with which B hits the ground. Right, now we have to use SUAT for this. Now, if you look at particle B, right, B will go down. So remember, when we do SUAT, we take a positive direction. So take downwards as positive. And now what do we have? Now remember, the pulley is released from rest. So U is equal to 0. Okay. A is equal to 2. S is equal to 4. And we need to find out. Okay, so which SUAT formula connects all of these? U square will just be 0, and 2AS will be 16, which means your velocity is 4. Okay, so B hits the ground. The reason I took S as 4 is because the displacement from B to the ground is 4 downwards, and we've taken downwards as positive, right? So S will be positive 4. Anyway, so we've got our velocity, which is 4 ms minus 1. So this is the speed with which B will hit the ground. Okay. Now, once B hits the ground, then we have to consider the second part of the question, which I will just come to. Right, so just before we move on to part 2, I just want to show you how the pulley system actually works throughout the different stages. Right, so you start off, so this is the stage A, where the pulley is being held in rest. Okay, then you release the pulley. Okay, so when you release it, B is the heavier particle, so B goes down, and A will go up because A is light. Now both of them are traveling same speed, same acceleration. That means they will travel by the same distance. Okay, so B goes down in this situation. B will go down by 2. Right, that means A will go up by 2. Okay, so what that means is once B hits the ground, it's gone down by 2. A went up by 2. So A is now a total 4 meters above the ground. Right? And B is obviously at the ground now. Okay? Now, once B hits the ground, the tension is now finished. Okay, because they are not both hanging in the air. One particle is obviously staying at the ground and just there. Okay, so tension is finished. Okay, that means T equals 0 after B has hit the ground. Okay, now A is in the air. Okay, when an object is in the air, that means the acceleration is only gravity. Okay, so your acceleration will be 10 or negative 10, depending on um, which direction you choose as positive. So if you take upwards as the positive direction, A will be negative 10. Right now, once B hits the ground, what will happen is the string will have a vibrating effect. Okay, so if you just imagine, let's say you have a ball attached to a string, okay, and then you hit that on the wall. Okay, if you hit that on the wall, what will happen is the string gets a shock effect and it starts vibrating. Okay? Now that's exactly what's happening in this stage over here. Okay? So B hits the ground. Okay, the string gets a shock effect, and what happens to A is it goes slightly more up from 4. Okay, so first it was 4 meters when B hit the ground. Now it goes up to maybe 4.4, 4.5, 4.6, whatever. We don't know. So that's something that we will calculate. Okay, so because of this vibrating effect, you can see here the string has become slack. It's vibrating. Okay. Right, so the string at A becomes slack because of the vibrating effect, um, and A keeps going up for a short time or distance. Okay, so this is a very temporary vibrating effect, as you can imagine. So A goes up for a very small time, and then it will come back to its original position when B hit the ground, which was at 4 meters. Okay, and this is the sort of the final stage where the pulley has then stopped again. Okay, so your string becomes taut because the vibration effect is finished. Okay, and A comes back to its original position. Now, if you look from here to here, okay, A was at 4 meters, and here again it's at 4 meters. Okay? That means it's the same position, right? So if you were doing suat from the second stage to the last stage, S is actually 0, right? Because it hasn't moved up or down in position. So if a question says, how long does it take for A to go from being taught and being taught again, then you can use S equals 0, right? Now we'll come back to that in future questions. Right, now one more thing, if you look at this stage here, the third stage, right? This is the highest point reached by A. Okay, the string vibrates. So this is the highest point reached by A. After this, it comes down back to here, right? Now, at the highest point, what happens? If you remember your SUAT lessons, at the highest point, V is equal to 0. Right, so often a question would say, find the time taken to reach the highest point, or find the distance up to the highest point. In that case, you would use V equals to 0. Okay. So going back to our question, now we were over here. So we've done the first part, which was before any particle hits the ground. We've got the velocity, which was 4. We've got the acceleration as well. Okay. Now, another thing to note is that okay, let's do this one. Right, so just I've just summarized it here. If one particle hits the ground, tension will finish and acceleration will change. Okay, so the other particle is only operating with gravity. Okay, we always make two models, one before and one after hitting. Okay, this is a very key point here. The final speed just before hitting will be the initial speed after hitting. Okay, so if we go back here, now this is the model. Now the final velocity we found was 4. Okay, so B hit the ground with 4 ms. Okay, that means straight after hitting, the speed takes time to change, right? It won't instantly change from 4 to 0. So the final speed before it hit the ground was 4. That means the initial speed after hitting is also 4. Okay, and then obviously the new acceleration minus 10 is applied, and then speed eventually becomes 0. But when you have an instantaneous change, then it stays the same for a millisecond, because it takes time for things to happen, right? When you apply brakes on a car, it takes time to come to a stop. So similarly in this case, okay, the speed before hitting will be the initial speed after hitting. Okay, so V before is equal to U after. Now the question that we did, velocity we found was 4. Okay, this was before hitting. Velocity was 4, A was 2. Right, now I've got the same example here. Let's just make it full screen. Right, so before hitting, we had acceleration 2 and velocity was 4. Okay, now v before is equal to u after. Right, make a note of that. So v before is 4. That means u after will also be 4. Okay, so we've got one out of the way. Right, what else do we know? Now, if you look at particle A, okay, now after what will happen is B will hit the ground, A will go up by 4. So A will be over here. Okay, and after B hits the ground, A will keep going up by maybe 0.2 or 0.3 or whatever. Okay, string will become slack. So straight after B hits the ground, A goes up. So what I will do is I will take up as my positive direction. Okay, now your acceleration will change, right? Because now the string is messed up and you only have gravity. Now gravity is 10 because you've taken air upwards as positive. A will be minus 10 because gravity always acts downwards. Okay, so we've got U, we've got A. Now let's look at the question. It says find the highest point reached by A after B hits the ground. Okay, now highest point always means V equals 0. Okay, so I will make a note here, V equals 0. Okay, when it says find the highest point, it means find the distance. Right, so which formula connects S is your displacement, right? So which formula connects S, U, A, and V? We use V square equals U square plus 2AS. Right now, V is 0. Okay. U square will be 4 square, which is 16, plus 2A is minus 10. And S we need to find. Right now, we rearrange this. So 20S equals 16, and S will equal to 16 over 20, which is 0.8. Okay, now it's important you get the final answer right. So what will happen here is initially both were 4 meters above the ground. Okay, so B goes down by 4, A goes up by 4, and then A goes up by another 0.8. So what's the total height above the ground? We had 4 plus 4 plus 0.8. So the final answer would be 8.8 meters. Right, so this is the first part. The second part says find the total time taken for A to reach its highest point. Okay, so you will do, again, we have two models before and after, right? So time before. Okay, now if you look at the model before, A is 2, V is 4. Now the pulley is always released from rest. Okay, so U is 0 at the starting. Okay. Using this, we can calculate T. If you do V equals U plus AT. Okay, so 4 equals 0 plus 2T. That means time will equal to 2. Okay, and time after. Now we are at the after model, right? Because the time before we've calculated as 2. Time after. Now V equals 0. I'm going to rub this off because I used that specifically because this question said highest point. Okay. Now, this question says total time to reach highest point. Okay, so it's saying highest point again. So we can use v equals 0. And from here, we need to find our time. We can again use v equals u plus at. Okay, and this will give us, so v is 0, 4 minus 10t. So the total time taken for A to reach its highest point is 2.4 seconds. Okay. Now you can see this was very small, 0.4, right? So when the particle hits the ground, and the particle has hit, this only lasts for a short while, only 0.4 seconds in this case, and then it comes down. Okay, we'll move on to the next question. If you're comfortable, you can pause it, try it yourself, and then resume the video. If not, you can do it while I am doing it. Right, so the pulley is released from rest. Now, the first thing you should always do is draw the forces, right? So, sorry, this mistake in the question, that should be A, and that should be B. Okay. Yeah, that's correct. The question now. Drawing the forces now, you will have weight going down. Tension going towards the pulley. Okay, now for particle A, A is heavier, right? So A goes down. So you do down minus up. 50 minus T equals MA. And A was going down and B is lighter, so B goes up. So for this, we have to do up minus down. So for B, we are doing up, which is tension, minus down, which is 30, equals 3A. Right, once you've got these, if you add both the equations, it will get rid of the T, right? So 50 plus minus 30 gives you 20. Yep, sorry, we're adding both equations simultaneous. You can do simultaneous or any other method. You'll get the same answer, right? So 50 plus minus 30 is 20. Minus T plus T is 0. And 5A plus 3A is 8A. So 20 divided by 8 gives you A equals 2.5. They haven't asked you to calculate the tension. If you want to, you substitute A back in and then find T. Okay, so we make two models, one before and one after. Right, pulley is released from rest, so U is 0. Okay, A is 2.5. They've told you in the equation the speed just before it hits the ground is 5. Okay, so that means the final speed, right? Just before it hits the ground, 5. And we don't have anything else. Now it says find the value of y. Okay, so y is the distance from A to the ground. Okay, so we are still working in the before model, right? Because this is before hitting. So That's the S we need to calculate, right? Now A is going down, so I'm gonna take down as positive, okay? And which formula from SUAT uses all of these? Okay, so V is 5 and 2 times A times S. So 25 equals 5S, which means S equals to 5. So Y will be 5 meters. Okay, that's part A done. And I'm gonna rub this off just to make it easier. Find the greatest height reached by B. Okay, so just to okay, S we found was 5, right? Now, just to show on the diagram what will happen, A will go down by 5. That means B will go up by 5. Yep. So B is now at 9 meters above the ground. After A hits the ground, the string gets a shock effect, and B goes even slightly higher. And we don't know exactly what that is. So that's what we need to find out. Okay. So now we are moving into the model after it hits. Okay. So remember your key point, V before, which I told you, yeah, equals U after. So V before hitting was 5. That means after hitting, U is 5. Okay. Again, because one particle has hit the ground, tension is gone, and gravity is just acceleration, which is minus 10. And greatest height means V equals 0. Okay, now this is just for this question, part B. It might not be applicable for C. And they want you to find the height. Height means S. Okay, so V square equals U square. So S is 1.25, which means the total height will be above the ground 4 plus the 5 plus the 1.25. Add that up, that gives you 10.25 meters. Right, part C is slightly tricky. Find the time from release to string becoming taut again. Okay, now first what we'll do is we'll find the time till A hits the ground. Okay, so that will be the before model. Right, so I'm going to use V equals U plus AT. V is 5 and U is 0 and T will equal to 2. So 2 seconds. Right, so this is the before model. Then we have to add the time after it hits. Right, now this is slightly different to the previous question. The previous question said, find the time for A to reach its highest point. And this is saying, find the time for the string to become taut again. Okay, so I'll just show you in the diagram what that means. Right, when it said find the time to get to the highest point, they were referring to here. Okay, when it says find the time for the string to become taut again, they are referring to here. Okay, because in this diagram, the string is fully stretched, fully taut. Right, now there's two ways to do it. Now this is the before. This part we've already done, the time taken to hit the ground. We calculated as 4 seconds. Or was it? I'll recheck. Sorry, that was 2 seconds. Yeah. This is done now. The time from here to there, there's two ways to do that, right? You can find the time to get to the highest point and then double it. Okay, so for example, it takes 3 seconds to get to the highest point. It will take 3 more seconds to get back down here. So that would be 6 seconds. Okay. The other thing you can do is you can just ignore this completely. Okay. If you go straight from here to here, S is 0, right? Because the position is the same. Remember, same position. It hasn't actually moved up or down. So you can take S equals 0 and calculate it directly. Now I will show you both methods, and then so that you know if there is a question where you can only use one method, then it's easier for you. Okay. Right. So first we'll do time to highest point. Right, now we calculated highest point means v is 0, so we will use that. Okay, we had a minus 10, u5. Right, now how do we calculate time using these three? We use v equals u plus at. So 0 equals 5 minus 10t. Right, so it takes 0.5 seconds to reach the highest point. Now, what that means is from here to here, it takes 0.5 seconds. Okay, and 0.5 seconds to get taut again, come down. Okay, so we had 2 seconds plus 0.5 plus 0.5. So that would be total 3. Right, so that would be 3 seconds. The other method you can use is directly becoming taut. Okay, so as I said, from the time it was first taut to becoming taut again, S is 0 because you can see it's in a horizontal line, same position. Okay, so we have, now I'm going to rub off V equals 0 because we are not using highest point, right? We are using S equals 0. Okay. Now we need to find time. So the best formula to use is this one. Half times minus 10 is minus 5. So you can see here. And you can take t common. So this will give you t equals 0, 5 minus 5, t equals 0. You rearrange that, t equals 1. Okay, and before was t equals 2, so 2 plus 1 will give you 3. Okay, so you get the same answer as the other method, right? So 2 seconds here, then from here to here, 1 second, right? So 3 seconds total, just how we got. So either method is fine. I prefer the first one. You calculate the highest and then double it, okay? But it's up to you which one you use. Right, final one. So this is from one of the past papers. So have a read and then we'll go through it. Right, P is 0.9. Okay, they've given you the tension, 7.2. Okay, it says that P goes down. Okay, so for P is going down, right? Because they've told you in the question. So down minus up equals MA. Now, going down is the weight, 0.9 times 10, which is 9. So down minus up equals MA, 1.8. Now we've got acceleration. Using acceleration, you can actually find out the mass of particle Q. Okay. Now the weight is 10 times the mass, so 10m. Q will go up, right? So up minus down equals ma. Okay. Now we know that acceleration is 2, so we can replace this with 2. Right, now we try to solve this. So 7.2 equals 12.2 m. M equals 0.59. Okay. Just to show you how it's done, so just remove that. And okay, P, we've got before we calculated acceleration, which is 2. The system is released from rest, which means U is 0. This should be Q. S is 2. Okay. we need to find v because v before is equal to u after, right? So we will do v square equals u square plus 2as. 2 times 2 times 2, 8. Okay, so after u is root 8, after hitting, tension finishes, so a will be minus 10. Right, now the question is saying, at the instant P hits the ground, Q is at the point X. Okay, so what will happen is, now let's just remove this tension. P will go down by 2 meters, Q will go up by 2 meters, right? So Q is over here. When it hits the ground, it was 2 before. Yeah. P went down by 2, Q went up by 2, so Q is at the point over here, which is point X. Okay. Now what will happen is, the string will become slack, Q will go up for a while, then it will come back down to point X. Yep. So we need to find the time, we need to find the distance from here and coming back down. Okay. So what I will do is I will use the method where it goes to the highest point and then I will double it. Okay, so highest point is v equals 0. Okay, and we are finding the distance, so we are finding s. Okay, so I will use this formula. V square is 0. U is root 8. Okay, let's try solving. So 0 equals 8 minus 20s, which means s is equal to 8 over 20, 0.04. Okay, so from here to the top, 0.04, yep, and comes down back to this point, 0.04 meters again. Okay, so the distance from here to here would be 0.04 plus 0.04, which is 0.08. Now, if it said distance, if it said total distance traveled from release, okay, then you are adding the extra 2 meters that it went up, 2.08. Okay, but in this question, it says from the instant it reaches X until it returns to X, and X is the point where P hits the ground. Not where P hits the ground, but X is the point at the instant where P hits the ground, right? So X is over here, right? So your total distance back up to down would be 0.08 meters. Okay, we'll stop there. Try the questions in the description, and then next lesson we will do situations where the string breaks, slightly more tricky.